All right, let's run through another Mtel question. This one says the average distance between Earth and Sun is that number right there, kilometers. When Mars and Earth are on the same side of the Sun, the distance between them is approximately 0.5 times the distance from the Earth to the Sun. A spacecraft is expected to take approximately 9 months to travel from Earth to Mars. Which of the following intervals is a reasonable estimate for the average speed of a spacecraft traveling from Earth to Mars? Okay, so they are giving us estimates, which is interesting. But what are they asking us for? That's probably a reasonable place to start. They're asking us for the average speed of a spacecraft traveling from Earth to Mars. And they're giving us distances and 9 months, which is a period of time. So I'm seeing speed, distance, and time. So we're going to be using one specific equation with those three variables, right? So the fact that speed equals distance over time is what I imagine we're going to be using here. So we're trying to calculate the speed, so it would be nice if we had a distance and a time to do that. We do have 9 months. That's how long it's going to take to travel from Earth to Mars. But we don't have the distance from Earth to Mars. What we have is the distance from the Earth to the Sun, but we also have the ability to find the distance from Earth to Mars because it's telling us that the distance between them is approximately 0.5 times the distance from the Earth to the Sun. So basically they're just telling us that the distance from Earth to Mars is half of the distance from the Earth to the Sun. I'm just going to round this number because they're giving us rounded answers. So I'm just going to say this is 150 million rather than 149 million and change, right? So if we just make this 150 million, then I multiply that by 1/2. 1/2 of 150 million is 75 million. So our distance is 75. Instead of writing a bunch of zeros, I'm just going to go mil. So that's D. That's D. That's our distance in our speed equals distance over time equation. And that's in kilometers. All of our answers are in kilometers per hour. The problem is that they're giving us 9 months, which isn't what we want. We don't want months, we want hours, because all of our answers are in kilometers per hour. So I know that the speed is 75 million over 9 months, but I have to figure out how to convert that to hours. So I'm going to use dimensional analysis to do that. I'm going to start with our value that we have here, which is 75 mil kilometers in 9 months. And then I'm going to play with the units here until I get into kilometers per hour, which is what I need. So I have to go to a much smaller unit of time from months to hours. So I'm going to just kind of step down unit by unit. So I know that there's 30, months is weird actually. Okay, so but we're estimating here. So months is kind of a weird unit of time because there isn't a standard amount of time in a month, right? Like some months are 28 days, some months are 30 days, some months are 31 days. But if we just use 30, all of the answers are estimated, so the number doesn't have to be exact. So I can just say that in 1 month there are 30 days, and that'll be close enough for what we're trying to accomplish here. And so the point of doing that is that our months units are going to cancel here. And now we are in, if we do the math out, we are in kilometers per day. So now we have to convert days into hours. Well, we can do that because we know that in 1 day we're going to have 24 hours. So now we can cancel days. And our remaining units are just kilometers per hour. So all we have to do is the math here. So we just multiply across the top, divide by the stuff on the bottom, and we should get our answer. So on top we've got 75 million times 1 times 1. And that's getting divided by the stuff on the bottom, which is 9 times 30 times 24. 9 times 30 times 24. And that gives us about 11 or 12,000. And since we're rounding, that puts us in the range of answer B.